equivalently, we could have used the other form of the derivative. The limit as h approaches 0, f of 1 plus h minus f of 1 over h, and show that this is D and E. So if such is the case, then we'll want to also use the two one-sided limits. So h approaches 0 from the left, firstly perhaps, of this difference quotient, f of 1 plus h minus f of 1 all over h. So if h is approaching 0 from the left, then on the curve, we are on the 2 root x function. And this follows from h approaching 0 from the left. Let's just look at this very quickly. H approaches 0 from the left is the same as x approaching a, I guess 1 in this case. I'll use the particular number that they gave us. X approaches 1 from the left. And this is because h is really the expression x minus 1, x minus a. Right? Always remember that h is x minus a. Right? So we have h approaching 0, and we have x approaching a, and down here I'm just giving it the particular numbers for this problem. So as h approaches 0 from the left, right, if x is approaching 1 from the left, right, which is conceptually clear in the picture, right, if x approaches 1 from the left, I'm clearly on the left part, right, I'm on the left part of this curve, not the right part. So over here, as x approaches 1 from the left, that would mean that for the expression x minus 1, the x values are always smaller than 1, because I'm to the left of 1. If the x values are always smaller than 1, then this expression here, x minus 1, this x is a value smaller than 1. A value smaller than 1 minus 1 will be negative. Right? So h would always be negative here. But what is h actually heading towards? H is always negative, but as x gets closer to 1 from either side, it doesn't really matter. H is still heading towards 0. Always negative, but approaching 0. So if something is always negative, yet approaching 0, it must be approaching 0 from the left of 0 from the negative numbers. Right? And then the same analysis follows for when x approaches 1 from the right. If x approaches 1 from the right, then the value x here is always greater than 1. A value greater than 1 minus 1 would always be positive. Yet, since x is heading towards 1, this little difference is heading towards 0. So h is still heading towards 0 when x heads towards 1 from the right, yet it's always positive. So that would imply that if h is heading towards 0 from the right, that would mean that x is heading towards 1 from the right. All right? So therefore, this left-hand limit, h approaching 0 from the left, is exactly the same as left-hand limit, x approaching a from the left. So we know that for this one, we must be on the 2 root x expression. So we'll have limit as h approaches 0 from the left of 2 root 1 plus h, again, just replacing f with the function we're supposed to be using at this point, the piece of the function we're supposed to be using at this point, minus f of 1. F of 1 is 2. We saw that before. That's not going to change. H. So again, taking the 2's out, it'll be another use of the conjugate to complete this limit. So 2 root 1 plus h minus 1 over h.